Look up at the night sky. What do you see? Countless stars, right? Now imagine all those stars are like marbles scattered across a giant trampoline. You'd expect the trampoline to sag under their weight. That's kind of what gravity does in space, it pulls things together. But here's the thing, when astronomers looked at how galaxies spin, something wasn't adding up. The stars were moving way too fast for the amount of stuff they could see. It was as if the trampoline was barely dipping, but the marbles were whizzing around at super speed. It was clear that something else was out there, something invisible, holding everything together. Something with a lot of gravity, but that didn't give off any light. They called it dark matter. So what exactly is dark matter? That's the million-dollar question, or should we say, the billion-galaxy question. Dark matter is one of the biggest mysteries in modern astrophysics. Scientists are still trying to figure out what this mysterious stuff is made of. They have many theories but no definitive answers yet. But here's what we do know. It doesn't interact with light like normal matter does. This makes it incredibly difficult to detect. Think about it this way. You can see your hand because light bounces off it and into your eyes. This is how we see most things in our daily lives. But dark matter doesn't reflect, absorb, or emit light. It's completely invisible to our eyes and even to our most powerful telescopes. It's like a ghost, passing right through walls and everything else. Imagine something that can move through you without you even noticing. We can't see it directly, but we know it's there because of its gravitational effects. It bends light around galaxies and affects the motion of stars. It's like trying to guess what's inside a wrapped present just by shaking it. You can't see inside, but you can gather clues from the outside. You can't see the gift, but you can feel its weight and maybe even hear a rattle. This is how scientists study dark matter, by observing its effects on the visible universe. One of the biggest pieces of evidence for dark matter comes from something called the bullet cluster, a fascinating and mysterious cosmic phenomenon. Imagine two clusters of galaxies colliding like giant cosmic billiard balls, smashing into each other with incredible force and energy. When this happens, the hot gas in the cluster slams together, creating a bright, X-ray emitting mess that lights up the cosmos. But here's the kicker. Using a technique called gravitational lensing, astronomers found that the strongest gravity wasn't coming from the hot gas at all. Instead, it was coming from somewhere unexpected. It was coming from a region offset from the visible matter, as if something invisible had passed right through the collision. This invisible force is what we call dark matter. Another clue comes from the groundbreaking work of astronomer Vera Rubin, who made significant contributions to our understanding of the universe. She studied how fast stars orbit around the centers of galaxies, meticulously measuring their speeds and trajectories. She found that stars on the outskirts of galaxies were moving just as fast as those closer to the center, like a cosmic merry-go-round where everyone, no matter how far from the center, goes the same speed. This was a surprising and puzzling discovery. The only way this is possible is if there's a lot of invisible matter, spread out like a halo holding everything together. This invisible matter is what we now know as dark matter, a crucial component of our universe. Scientists are like detectives, piecing together clues to solve the mystery of dark matter. They meticulously analyze data, run complex simulations, and collaborate with experts from around the world to understand this elusive substance. They use incredible telescopes, both on Earth and in space, to study the cosmos. These powerful instruments allow them to peer deep into the universe, capturing light from distant galaxies and stars. They look for subtle distortions in the fabric of space-time caused by the gravity of dark matter. These distortions, though minute, can reveal a lot about the unseen forces shaping our universe. They even build giant detectors deep underground, hoping to catch a glimpse of dark matter particles as they pass through the Earth. These detectors are shielded from cosmic rays and other interference, making them ideal for such sensitive experiments. It's a tough job, but these scientists are determined to crack the code. They venture into remote and challenging environments, driven by the quest for knowledge and the thrill of discovery. The search for dark matter is one of the most exciting frontiers in modern science. It brings together brilliant minds from various fields, fostering collaboration and innovation. It's a reminder that there's still so much we don't know about the universe, and that the biggest discoveries might be just around the corner. Every observation, every experiment brings us one step closer to understanding the cosmos. So the next time you look up at the night sky, remember that there's more out there than meets the eye, a hidden universe waiting to be explored. The mysteries of dark matter are just one piece of the vast puzzle that is our universe.